So, good morning. We are going to discuss about non-inverting operational amplifier. In this non-inverting operational amplifier, input is connected to the non-inverting terminal. So, because of the applied this input voltage, there is some voltage is produced at the output side. So, that voltage we call it as a V naught. V naught. So, due to this V naught, there is some current is flowing through this feedback resistor. That current I call it as an IF, feedback resistor current IF, and I'm assuming this one as a node. So the this node I calling it as an VA. So VA is equals to VN because of virtual ground concept. V1 is equals to V2. Let us assume this one is V1, that nothing but a VN. So this is V2 nothing but a VA. So now according to the virtual ground concept, V1 is equals to V2. So whatever the voltage at the V1, that is Vin, is equals to VA. Now because of this VA, there is some current is flowing. That current I call it as an I1. Now applying the KCL, so at the node VA, so I1 is equals to IF. I1 is equals to IF. So if you write the equation for I1, then what it is? So VA minus 0, VA minus 0 by the resistance is R1, VA minus 0 by R1. Now if you write the equation for IF, so IF is equals to V naught minus VA by what is the resistance? Resistance is RF. So I'm writing it as an RF. Resistance is RF. So just split this one so that this entire equation is equals to VA by R1 is equals to V naught by RF, and minus VA by RF. Now bring this VA to this side and take VA as a common. So we'll get this equation as VA by R1 plus VA by RF equals to V naught by R1. This entire thing I am writing here, V naught by RF, not R1, and this is RF. V naught by RF. This one is VA by RF. Now take a VA as a common. So give me some time. I'm going to clear this screen so that we'll get more space. So now take VA as a common from this equation. VA as a common. So V naught by RF is equals to VA 1 by R1 plus 1 by RF. Okay, this is an equation. So now what I am writing now? So as already I said that VA is equals to V1. That means V1 is equals to Vin. That is the input voltage which is applied at the non-inverting terminal of op amp. So I'm replacing this VA with Vn. So and also I'm going to take this RF to this side. So V naught is equals to what I get? V naught equals to Vn into VA is replaced with this this input voltage, because VA is equals to V1, that is equals to VA. Okay, now Vn into RF. I'm writing RF inside, so that RF by R1 plus RF by RF. So RF by RF value is 1, I think. RF by RF. Now this entire equation can be written as V naught is equals to this value is 1, this value is 1 plus Rf by R1, 1 plus Rf by R1 into Bin. Okay, this is the output voltage expression. Output voltage expression for output voltage expression. This is the output voltage expression for non-inverting operational amplifier. From this expression, if you write the gain equation, then how to write the gain equation? V naught by Vin. So V naught by Vin is equals to 1 plus Rf by R1. So that can be written as 1 plus Rf by R1. So from this equation, I got this equation. So this is a voltage gain equation and this one is output voltage expression. Okay, this is all about a non-inverting operational amplifier.